Hey everybody, let's do some exercises to learn some NumPy mathematical functions. So you can follow along with me by downloading the Python notebook linked below. I have two notebooks. I have an empty notebook with just the questions, sort of like what you see right now on the screen. And then I have a solutions notebook with all the code for the solutions. And then also I have a link to the data set that you're gonna need for this notebook, and also a link to my lecture on NumPy mathematical functions. So you can watch the lecture first and then try out these exercises and questions, and then use the solutions notebook to basically double check whether or not you coded it up correctly. All right, so let's get started with some of these questions or of these exercises. I'm going to execute this line of code. It's going to import NumPy. And then for these questions here, we want to use these arrays. So I'm going to execute this line of code. It's already written out for you, but let's look at what these arrays look like. The first one is X. It's 9 elements long. And then the Y array is a multi-dimensional NumPy array 3x3. Size is 3x3. All right, so the first question or the first exercise is, what if we want to print the results of adding, subtracting, and multiplying X for the most part? And so what it kind of means is like, well, how do you multiply? If I wanted to add 3 to the array, or subtract 2, or multiply 2 to the array, how would I actually do that? So that's pretty easy. We're just going to use the basically symbols to represent the function. So if I wanted to add 3 to the array, I just do plus 3, as simple as that. If I wanted to subtract 2 from the array, I can just subtract 2 like that. And then if I wanted to multiply the array by 2, I just use the multiplication symbol. And if I print everything out, I should get basically 3 arrays. The first one is add 3, the second one's subtract 2, and then the last array on the bottom is multiply the entire array by 2. And that's exactly what I see and what I got. So a little bit more complex is negation, which is multiplying the array by -1, exponent, and using the modulus operator. So negation, so multiplying it by -1, there is a simple way of doing that, which is using just a negative x, and that's what negation is. And then if I want to take the exponent, so say I want the array as the base, and I want to take 3 as the exponent, I can just do a double asterisk and put 3. And then if I wanted to use the modulus operator, the modulus operator is basically a percentage sign. I'm just going to use divide by 3. And let's see what I get. So I get the negation, so it's multiplied by -1. I am taking the exponent, the third, basically an exponent of 3 to all of the elements in my X array. And then basically the modulus will tell me if there is a remainder and what that remainder is when I divide the array by 3. Right, so that's exactly what I am expecting to get. And then the last one is to divide the array by 4 using the NumPy function, right? So we're not going to use an operator, so we're not going to use this divide operator, but instead we're going to use this np divide function. And so what's the syntax for that? You just do np.divide, exactly what it says down here. And then I'm just gonna call the array here and divide it by 4. And I should get the correct result. So that's pretty simple. Next, let's take a look at absolute values. So there's a question here of just printing the absolute value. So that's pretty easy, just print X. So let's look at what this looks like. So this is a an array that starts at -4 and ends at 4. And then let's now print the absolute values of x. So in order to do that, I will just take abs as the function and print the absolute values here. So now all the negatives have turned into positive integers. All right, and so now we're using a complex, we're using an array with complex numbers. So I'm going to first print this array. It should look something like this. And now if I wanted to take the absolute value of that, that's pretty easy. I'm just going to print absolute value of x. If I execute that, I get real numbers here, and that's exactly what I'm expecting to get. All right, so that's pretty simple also. Now let's take a look at trigonomic functions. Let's create a function or create an array called theta. Let's print theta also. So we have 3 elements in this array here. Now, if we wanted to take the sine, cosine, and tangent, like what would be the functions I would use to take the sine, to take the cosine, and the tangent of theta? So what I could do is just pretty easy. It's sine, and then put in the array variable, which is theta. Same thing for cosine. It's cos, and then the array, and then same thing with tangents, tan, and then the array variable. All right, and so if I execute that, I get the sine, cosine, and tangent of the array theta. So same thing for arcsine, arccosine, and arctangent of element x. So what I'm going to do actually is copy this above code, because it's going to save me time in terms of just typing everything out. And I'm just going to change it up and say arc. It's also of elements of the array in x. So we are going to change theta to x. And then we're going to use the function arcsine, arccosine, arctangent. Right? And then if I execute that, I get the arcsine, cosine, and tangent of the elements in array x. So that's pretty self-explanatory. Like the hard part is really remembering the function names. And if you don't remember that taking the sine, you need the sine function, or arcsine is arcsine, you can always go to the NumPy document. The documentation is online, and just type in sine, or like how to take the sine of an array, and you should be able to find the documentation, right? Another way of doing that is also going to Stack Overflow. That's typically how a lot of people learn, is on Stack Overflow. Let's now look at exponents and logs. So I have this array here, 1, 2, 3, and all I want to do is basically take the exponent of it, raise it to 2 to the exponent of x, and then 5 to the exponent of x. So basically, like, how do we do that? There are several ways, but in order to use some of these NumPy functions, here's one way to do it. So I'm going to do some print statements. So I want e to the x, so e to the array, and then I'm gonna try to format it as best I can so it looks nice when it's displayed. I'm going to use the exponent exp function for this array, and then what I'm going to do next, I'm actually going to copy this line to the bottom, and then it's really 2 to the exponent of x. And then if we have a base 2 and x, our array is actually the exponent, we can do this shorthand exp2, and that will force the base to be a 2. Copy that and put it to the bottom. Now we want the base to be 5. And this function will have to change. We're going to do the power function with base 5 and to the power of the array x. All right, and so if we execute on that, we get exactly what we think we're going to get. All right, so now dealing with logs, well, how do we take the natural log of x, log base 2, and log base 10? Well, there's functions exactly for that. I'm going to actually, again, copy the above down here because it's just so much easier to type out. I'm going to do basically the natural log of x. I want log 2. And then I want a log 10 for x. And all that's going to change now, I'm just going to reformat this a bit, is my functions. So for a natural log, I can just call the log function. For a log base 2, it's, you probably guessed it, log 2, and then a log 10 for the log base 10. Whoops. This is what happens sometimes when I'm too fast. So delete that, and I get what I expect to get. Natural logs, log 2 and log 10. And again, look at the documentation. If you don't have these functions memorized, most people don't have them memorized, and will have to either search on Stack Overflow or just read through the NumPy documentation to find what functions they need to use. All right. So let's use this last section right here. Let's use some of these functions. The exp PM1 function, which is equivalent to this operation here. You know, really the only difference is that it increases the precision. So what we're going to do is essentially show that the precision is different between actually performing the operation and using this expm1 function. So we have this array z here. And what I'm going to do first is I'm going to use the NumPy function, the expm1 function. And the way I want to do that is I'm going to do a print and then exp of the z array minus 1 is equal to, and then I'm going to call the function that I want to use, expm1 of the z array, right? This one is more precise than actually doing the operation itself. And so I will try to show that to you as best I can. So actually, let me just copy and paste the above from the above. All right, so it's the same thing here, but what we're gonna use instead is that we're gonna just do the actual operation. So it's exp, so the exponent function of z, and then we're just gonna subtract 1 from it, all right? So if we execute this code block, the first line is using expm1 here, and you get this. And the bottom one is when I actually manually perform that calculation by taking the exponent and then manually subtracting by 1. There's a difference, as you can see, in this second column, third column, and fourth column. And if you use this expm1, it's supposed to be a lot more precise. And you know, it's really off by a very small amount. But as you scale up, like if you're gonna take an exponent of this later on or multiply it by like a large number, small little differences become huge differences later on, and then your result at the end of, you know, your model or end of your calculation is not accurate. It's off by a lot, and this could be the reason why, because you started off with a very small difference in precision.